Example 4, same idea. This time again, if it's a coin problem, Parker has nickels and quarters. He has 2 more quarters than nickels.
I have a dime and a penny.
Well, you have nickels and quarters in this problem. And he has 2 more quarters than nickels, and the total amount of money he has is $2.90. How many of each type of coin does he have? Again, that's the problems we're going to be getting to here shortly, coin problems, and we're going to have to set up a system of equations to solve them. And when we get to that point, we'll understand that. Not that bad. Now, one thing I want to show you about this that I didn't do on the last problem, but it's something to think about. A lot of times in coin problems, one of your equations can all be divided by the same number. That is legal, and it's worth doing usually. Okay? Notice the top equation I've got circled in blue there. It doesn't even matter if it makes things work better. If you can make numbers get smaller, it's usually worth doing. So every one of these numbers, 5, 25, and 290, divide evenly by 5, right? So if I divide by 5, I end up with 1 n sub n. I'm just going to write down n though, because I'm using the subscript as my variable. Plus 5n sub q, so I'm going to write plus 5q, is equal to 290 divided by 5, which is 58. So the equation I've written in blue there is equivalent to one I've got circled in blue. I just divided everything by 5 and used the subscripts themselves as the variables as opposed to the n sub n and n sub q. All right. The bottom equation I'm going to keep as is, but again I'm going to write it as q equals n plus 2. All right. So, looking at this problem, the way it's set up, and again, the way it's set up establishes for me how I'm going to go about doing it. So if it's each letter 1 plus letter 2 equals number on both, I'm going to use elimination every time. But if I've got one of the equations that looks like this, q equals everything else, substitution is a lot quicker. So I'm going to replace this q with an n plus 2. So the top equation changes to n plus 5 parentheses n plus 2 equals 58. If you substitute more than one thing for one thing, parentheses are required. So I'm replacing one thing q with 2 things n plus 2, parentheses required to allow that. 5 is being multiplied by q, so now 5 is being multiplied by the entire replacement. So 1n plus 5n plus 10 equals 58. Move the 10 over. I get n plus 5n makes 6n. 58 minus 10 is 48. Divide by 6, we get n equals 8. Q is n plus 2, so if I just do this, 8 plus 2 is equal to q, right? So q would equal 10. Just like that, we get both values. And again, n equals 8, q equals 10. I know what you mean. If you want to write it with subscript variables, n sub n equals 8, n sub q is equal to 10. That's fine also. I'll take either set of answers. No ordered pairs required on these because, again, there's no x's and y's. And just so you know, how much is 10 quarters worth?
250.
250 cents, right? That's a C, like a cent. And how about 8 nickels?
What?
40 cents, right? If they add those up, how much is that?
290.
290 cents. Get the correct amount of money. 2 more quarters and nickels. So again, that's where we're going with these. Going to be coin problems. They're going to give us some facts about the coins. We're going to have to write equations to represent those facts. We can find out exactly how many coins whoever is involved in the problem